Hello and welcome. Today we're looking at electronegativity and polarity, and this is part of Organic Chemistry 1, and today's presentation is brought to you by Science Visualized. So question number 1. Give a brief description or a diagram or drawing showing symmetric covalent bond. In symmetric covalent bonds, the two atoms are similar or have very close electronegativity value. So for example, if you have an X and an X sharing electrons, each of them gives one electron. The electrons are equally shared, and that becomes a symmetric covalent bond. The other type of covalent bond is called polar covalent bond, and that's where the electrons are not equally shared. So for example, if you have an X and say you have a Y, and if Y is stronger in electronegativity value, so we say delta minus, so partial negative, and X will be weaker in electronegativity, we give it a partial plus, then the bonding or shared electrons will be closely attracted towards more electronegative element, which is Y in this case, and therefore the electrons will be closer to Y than X, and therefore X has a partial positive. And you can also use dipoles to show electronegativity, where the head faces the partial negative, and then the tail, you cross it to look like a plus, faces the partial positive. Question 2. It says, use increases or decreases to describe electronegativity as it varies from top to down on the periodic table. So if you look at the periodic table, it looks like this. And then here you have group 1A, and then here farthest to the right you have group 8A, and those are the inert gases. And then just before group 8A you have group 7A. The electronegativity increases across the periodic table, so increase, and also increases up the group. So we will say that on the left is going to be partial plus, on the right until you get to group 7A it's going to be partial negative. The most electronegative element in the periodic table, right in this corner here, is going to be fluorine. And then the least electronegative element will be on this other corner. Question 3. It says, does the H3N, that's basically NH3, which is ammonia molecule, have a dipole moment? Is it polar? Explain by drawing and showing all the dipoles and the resulting dipole moment. So first of all, we have to draw a three-dimensional representation of ammonia, where nitrogen is the central atom, and then you have two hydrogens on the same plane, because that nitrogen is sp3 hybridized, so it's tetrahedral, and then you have the other hydrogen coming out, and then you have the remaining electron pair going in. So we see that nitrogen here is tetrahedral, so I'll say sp3, which means it's tetrahedral geometry. Now if you look at the electronegativity value and you look at the periodic table, you will see that hydrogen is in group 1A, and then nitrogen is in group 5A. And we know that electronegativity increases as you go to the right, and because of that nitrogen will be partial minus, while hydrogen will be partial plus. So we could just go ahead and indicate partial minus on the nitrogen and delta plus on the hydrogen. But the best way to show this is to use dipoles. So this word here, dipoles, and dipoles are drawn like this, where the head faces a partial minus and then the tail faces a partial plus. In this case, nitrogen is partial minus, so the head is going to face nitrogen and the tail will face hydrogen. Same thing here and same thing here. Now here we have electron pair, and the electron pair is going to be very strong in electronegativity value, and because of that we will draw a much longer dipole there. Now the next thing is dipole moment, and we get dipole moment by adding all the dipoles. So when you add that dipole, that dipole, that dipole, and that dipole, you get what's called a dipole moment, mu, and mu is not equals to 0. Actually, mu will be something that will look like that. And because mu is not equals to 0, we'll say that this molecule is polar. So we'll say mu is not equals to 0, and therefore NH3 is polar. So does the molecule have a dipole moment? Yes. Is it polar? Yes. And then explain. And here, this diagram explains. So you can just summarize and say NH3 is polar since it has a net dipole moment. We just say mu is not equals to 0. Last question, number 4. Calculate the formal charge on nitrogen. So basically we're looking at that nitrogen, this nitrogen, that carbon, and that carbon. Formal charge equals to number of valence electrons in the free atom minus, so I'll say valence electrons in the atom. Formal charge equals to number of valence electrons in a free atom. So nitrogen, we know that nitrogen is in group 5, and therefore the number of valence electrons in group 5 is going to be 5 minus valence electrons. So the valence electron in this case, you have 1, 2, 3, and 4. And then for each bond you count 1. So there's 1 and 1 there. So a total of 6. So minus 6. And the result is going to be negative 1. And therefore that nitrogen has a formal charge of minus 1. Now for this other example, formal charge equals to valence electron in a free atom is 5 because nitrogen is in group 5, and then minus the valence electron in this example. So you have 1, 2, 3, and 4, which gives you plus 1. And then on this carbon, formal charge equals to number of electrons, valence electrons in a free atom. Carbon is in group 4, so it's going to be 4, minus, in this case, each bond has 1 electron from carbon, minus 4, and that gives you 0. So the formal charge of carbon in this case is 0. Here we have these 2 electron pairs on carbon, and therefore the formal charge equals the number of valence electrons of carbon in a free atom, group 4a, has 4, minus the number of valence electrons on this carbon. We have 1, 2, 3, 4, and 5. So we have 5, and that gives you minus 1. Thank you very much for listening. Please support the channel by subscribing.